Hi there, this is Miss Wesley, and we are starting a new unit today. Our new unit, Unit 8 here, is all about quadrilaterals. So we're going to spend the first lesson today talking about the properties. So your essential question is, what are the properties of each quadrilateral that I need to know? So each quadrilateral has different properties that we're going to focus on, but we're actually going to start with triangles, which these hopefully you guys do remember because we have talked about these all the way back since the beginning of the year. So take a minute to copy your essential question down. Again, it says, what are the properties of each quadrilateral that I need to know? And then we're going to jump right in here to triangles as a little recall. Okay, so if we start here with triangles, we're going to start with our right triangle properties. In a right triangles are special because they simply have one right, that should be an RT, right angle. I'll spell it out down here if we need to. And again, those right angles are 90 degrees. So as you can see in our picture, we have our 90-degree angle right there. So if you see a 90-degree angle, your triangle is officially a right triangle. Moving on, isosceles triangles. So we talked about these for quite some time. Isosceles triangles are special because they have two congruent sides, and because of that, they also have two congruent angles. So if I was to use this picture here, I'm going to let AB be congruent to BC. So what that would mean are that the angles across from those sides are my angles that are going to be congruent. So I would say angle A is congruent to angle C. So off to the side here, if I want to write that down, angle A congruent to angle C. And we also had said that side AB was congruent to side CB. So isosceles, two congruent sides, two congruent angles. A special case of that could be that you have a right isosceles triangle. So we're simply going to put these first two examples together. We're still going to keep our two congruent sides. We're still going to keep the two congruent angles, but we're going to go back and add in one right angle. So looking at this picture here, angle A is definitely going to be my 90-degree angle. I'm going to let AB be congruent to AC. And again, because of that, the opposite angles, or angle B, would have to be congruent to angle C. So if we wanted to write that piece of information out, we would say angle A equals 90. We could say AB this time is congruent to AC, changing it up a little bit, and angle B is congruent to angle C. All right, so hopefully none of that is a surprise or anything new for you, but if it is, take your time to understand that there. Call Miss Griffin and myself over if you're not comprehending it. But I'm going to slide down here and look at some other types of triangles. So the next type we have is a scalene triangle. So scalene triangles are special because they have no congruent sides, which means they're also going to have no congruent angles. So how they would look is each side length, so AB compared to BC compared to AC, would each be a different side length, hence why I put different markings on each. And each angle would also be different. So if I put one arc on angle B, if I put two arcs down here, and three arcs on A. So that's a scalene triangle. No congruent sides, no congruent angles, so I can't write any congruent statements like what I had done over here because there's nothing congruent since it is scalene. Again, a special case of that would be a right scalene triangle. So starting with our scalene properties, it's still going to have no congruent sides. It's going to have no congruent angles, but it is going to have one right angle. So looking at my picture again, I'm going to let A be my right angle. So I can say angle A, I just put a 9 for no reason. Let's try that again. Angle A equals 90. And then using my side markings, I'm going to let 1 mark for AB, 2 for BC, 3 for AC. Doesn't matter what order you go in, again, as long as they're all different. And then I'm going to put 2 marks on B, and I'll put 3 marks on C. So scalene right triangle, it's scalene in that none of the sides and none of their angles are equal, but the right part of it means that we are going to have that right angle that we have down here. And our last one, equilateral triangle. Again, look at that root word there, equal. So equilateral triangles have 3 congruent sides and 3 congruent angles, hence equilateral. So all the sides are going to be the same, so they each get a mark. And likewise, all of the angles are going to be the same, so they all get a mark. So I could write out here that AB is congruent, come on, or not, there we go, to BC, which is congruent to AC. And then I can also write out that angle A is equal to angle B, which is equal to angle C. And because they're equilateral, think for a second, what are each of those angles going to be? They're going to be 60. 180 divided by 3 would get you 60 degrees for each. So if you were ever asked to prove a triangle is a certain kind of triangle, whether it is equilateral, whether it's scalene, or maybe more specific like right scaling, you simply have to identify the pieces or the characteristics that you know and then back that up. So we're going to focus this unit on quadrilaterals, but the same would apply for a triangle proof if you were looking at it. So I'm going to flip over to the next page and we're going to start talking about quadrilateral properties. Okay, so what we have here, like what you are looking at in this entire space, this is what I like to call the quadrilateral family tree. So notice that a quadrilateral is at the top. Okay, that's the most basic 4-sided shape that we can have. Any shape with 4 sides is considered a quadrilateral, hence the word quad. From there, it can follow 2 branches. It could follow the trapezoid branch, or it could follow the parallelogram branch. We're going to focus on the parallelogram side of this. Sometimes they do ask about trapezoids, so you might see some of those in the practice problems or maybe even a CFU, but we're going to spend a good chunk of the time today focusing on your parallelogram properties because those are the more commonly asked questions and characteristics that you do need to know. So this chart, as you can see, breaks down the different characteristics. So once you know your shape's a parallelogram, then it could break off into 2 branches, either being a rhombus or a rectangle. And after that, as the shapes get more and more specific, the most specific shape you can end at here is a square. And a square, as it says, is simply a rectangle and a rhombus combined. It takes all of these characteristics and lumps them into one, known as a square. So yes, some of the characteristics are listed out for you here, but I'm going to go down and actually write them out for each shape, and this is what you really want to focus on. Alright, so let's scroll down here. Can I get the whole thing? Perfect. Alright, so let's start with parallelograms. So like I said, this is kind of at the top of the parallelogram sort of the branch. So we've seen parallelograms before, and we know a couple things about them. We know that their opposite sides are both parallel and congruent. So I can show that by putting marks on AD and CB because they would be the same length. So would CD and AB, those two would match. If you think back to how you indicate parallel, you put these little arrows on the sides. So those 2 sides are parallel, just like my other 2 opposite sides are parallel. So if you have a shape and it meets those characteristics, 2 pairs of opposite sides parallel or 2 pairs of opposite sides congruent, it's automatically going to be a parallelogram. Something else we know about parallelograms are that their opposite angles are in fact congruent. So what that would mean is that angle D and all of angle D here would be congruent to all of angle B. And likewise, all of angle A, notice I'm putting 2 marks there, would be congruent to all of angle C because these are opposite corners. Okay. Last thing we know is that the diagonals of the parallelogram bisect each other. That's not a very large space for me to write, so I'm going to write it down here. The diagonals bisect each other. So again, thinking back, bisect means to split something in half. So D to E, I need, 3 marks? 1, 2, 3. Would be the same as BE, 1, 2, 3. And then A to E, 1, 2, 3, 4 is going to be the same as 1, 2, 3, 4, CE. So the diagonals split each other halfway. All 4 pieces, so 1, 2, 3, 4, those are not all going to be congruent, but only the pieces on the same line will be congruent. Okay? So if you're dealing with a shape and it has any of those characteristics, that's enough to prove that it is a parallelogram. Let's jump down here now to a rhombus, though. So a rhombus is a more specified type of parallelogram. So notice that the first thing it says is it contains all the properties of a parallelogram. Because if off to the side here I was to draw out my parallelogram family. So I'd start with a parallelogram. Then you have 2 branches. You can either go rectangle or you can go rhombus. All right, so in order for something to be a rhombus, it has to first have all of the parallelogram properties. Once you know it's a rhombus, though, it also has some properties of its own. We know that all of the sides are actually congruent, if I can draw the congruent symbol. So meaning that each of the sides is the same length. Okay, that's special about a rhombus. Also, the diagonals are actually perpendicular to each other, meaning that they make 90-degree angles. So where the diagonals meet, and in this case it would be W, you would get a right angle there, and you'd actually get right angles going all the way around. Okay? That's a very special characteristic that the Regents loves to ask, so I would almost put like a star by that one. And the last thing you want to know is that for a rhombus, the diagonals bisect, again, I'm not going to be able to write that there, opposite angles. So looking at this here, S I would split into 2 equal pieces, V would get split into 2 equal pieces. That's not a very good arcs. Likewise, T, I could put 2 marks there, would be equal to this 2 marks there. These 2 marks would equal these 2 marks. So, yes, the opposite angles entirely, like all of S would still be also equal to all of V, but the left and the right side are now going to be equal to each other as well. So, those are your special characteristics about a rhombus. And again, if I'm going too fast at all, just pause, go back, refresh, and start over for me. Or just take a little break and come back. You know what I'm saying. All right, rectangles, 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 rectangles. Hopefully you've heard of rectangles before. Again, if you look back at this family tree here, we start with a parallelogram. A rectangle is a sub-shape of that, so it has to first have all the properties of a parallelogram. So everything that we talked about up here still holds true for both a rhombus and a rectangle. But what's special about a rectangles are that their diagonals are not perpendicular, their diagonals are actually congruent. So meaning that, this one's kind of hard to show, but A to C is the same length as D to B. Those are the same length. I'm putting 2 just so it looks like something rather than just a random line. So diagonals are equal, and hopefully you know this one already about a rectangle, just maybe haven't thought about it lately, but all the angles in a rectangle are actually 90 degrees. So meaning that each of these corners is going to give us a 90-degree angle. So, important one to note here is this one, diagonals are congruent. The Regents loves to ask about which shape has congruent diagonals, and your answer would be rectangle. All right, last shape, squares. We've dealt with squares for a long time now, since you were probably in elementary school. And again, if you go back and think to this family tree I got going here, starting at the top of the parallelogram, then I can break off in either a rectangle or rhombus, and after that, a rectangle and a rhombus combine to make a square. So a square has all the properties of a parallelogram, it has all the properties of a rhombus, and it has all the properties of a rectangle. So meaning that if you think about the key information here, it has 4 congruent sides, that's the rhombus part of it. It's got 4 right angles, that's the rectangle part of it. But then its diagonals are also going to be congruent because that's the rectangle part of it. It's hard for me, I don't want to get crazy here. But the diagonals are also going to make right angles, and that's another characteristic coming from the rhombus. So if you can kind of remember this generic breakdown here, that a square is the most specific type versus a parallelogram is the most generic, that would help you out. And then again, these key differences between the shapes. So I know that was a lot of information I just threw at you there, but we're just going to take a look at a couple multiple choice questions of how the Regents has asked these types of property or characteristic questions in the past, so you know what to be prepared for. Okay, so here we are for the last couple questions. And again, these are all Regents multiple choice questions. So this is how you'll see the characteristics or properties presented to you. So let's break them down. It says, given three distinct quadrilaterals, a square, a rectangle, and a rhombus, which quadrilateral must have perpendicular diagonals? Okay, and if you look at the choices, it's like a rhombus, rectangle, and square, rhombus and square, or rectangle, rhombus, and the square. So this is a good time when you want to draw out that little parallelogram, little family tree that I was telling you about. So we got parallelograms, then we break down into the rectangles or rhombuses, and then those come together to make a square. So thinking back here, perpendicular diagonals. Remember what's special about a rhombus is that it has four congruent sides. Ooh, that's definitely not very good. But I like to think of a rhombus as a tilted square because it has those four congruent sides, and then when you tilt it, you get those 90-degree angles in the middle around the diagonals. So rhombuses definitely have perpendicular diagonals. That's a very special characteristic you need to know about them. So what that means is if a rhombus has perpendicular diagonals, rectangles do not, because rectangles and rhombuses don't share a lot of characteristics besides the parallelogram ones. So if a rhombus has perpendicular diagonals, anything below it also does. So meaning a square would also have perpendicular diagonals. So if we look at our choices here, it's not just the rhombus, we need the rhombus and the square. So choice 3. So again, it goes back to that tree, and that if a rhombus has a characteristic like perpendicular diagonals, anything below it will also have that same trait. Okay, let's look at this one. Which statement is false? All parallelograms are quadrilaterals, all rectangles are parallelograms, all squares are rhombuses, and all rectangles are squares. Whew, that's very confusing. So when in doubt, I'm going to draw again my little family tree here. Rectangles, rhombus, oh, what happened to that? And square. Okay, so again, like we've talked about, if I am a square, that means I have all the characteristics of a rhombus, a rectangle, and a parallelogram. But say I'm a rectangle, rectangles are not squares because squares have extra things that rectangles don't. So if I break this down here, the first question says, all parallelograms are quadrilaterals. Well, that is definitely true because parallelograms have four sides, and that's what quadrilaterals have, and all of these shapes as well also have four sides. So it's not going to be choice 1 because that's true. It says, all rectangles are parallelograms. Well, if I look at this, my rectangles are under my parallelogram, so that is another true statement, because in order to be a rectangle, I first have to be a parallelogram. Choice 3. Well, actually, let me cross off choice 2. Slash the trash. All right, choice 3. All squares are rhombuses. So is every square, if I am a square, does that mean I'm also a rhombus? Well, in fact, it does, because a square, again, holds all of the same rhombus characteristics. So that's another true. All right, so it's got to be choice 4. Let's check it out. All rectangles are squares. Well, if I'm a rectangle, it doesn't mean I'm necessarily a square. And again, if I was to draw that out, here's my rectangle. Yes, I have 4 right angles, but my sides are definitely not all congruent. So therefore, not every single rectangle is going to be a square. Some might if you shrink like these two sides in towards each other. But this answer right here is, in fact, false. Okay, let's take a look at these last 3 here. So, next question says, a parallelogram must be a rectangle when it's what? So, again, when in doubt, draw your little tree here. So I got rectangles, I have rhombuses, and I have squares at the bottom. So, let's go through each choice. It says, parallelogram must be a rectangle when its opposite sides are parallel. Well, just because a shape, and again, if I draw a rectangle here, just because opposite sides are parallel, that doesn't mean that it's necessarily a rectangle, because I could also draw, I'm going to go over here, I could draw myself a parallelogram. Those sides are parallel, but it's not a rectangle, so it's not choice 1, because this time it's looking for a true statement. It says when opposite sides are congruent. Well, again, I can make it so these sides are congruent, but I could have done the same thing over here. These sides are also congruent, and that's not a rectangle. Diagonals are perpendicular. So if I draw in my diagonals here, even if you look at those diagonals definitely do not look like they'd make a 90-degree angle. For instance, this angle right here looks way too small. So it's not going to be choice 3. And if you remember, perpendicular diagonals belong to a rhombus. So the last choice, choice 4, diagonals are congruent. Again, go back to where I drew in this diagonal for my rectangle. 1, 2. Those diagonals are congruent. A rectangle has congruent diagonals. That's their special characteristic, because if you think about, I'm going to make this a little bit bigger here. If you think about outlining them, this triangle, we know, this triangle on the left here, that triangle would be congruent, ooh, haven't used that word in a while, to this triangle over here. Therefore, their diagonals must be the same length. That's another way to think about it. Okay? Okay, last two. Here we go, almost there. In a parallelogram, ABCD, diagonals AC and BD intersect at E. Which statement does not prove parallelogram ABCD is a rhombus? Alright, so the first thing I'm going to do is I'm going to draw myself a picture because they didn't give me a picture here. So I have a parallelogram. I'm going to start down here, A, B, C, and D. It says my diagonals AC and BD, so I'm going to draw those diagonals in. A to C, B to D. It says they intersect at E, so this point in the middle here is E. Which statement does not prove that it is a rhombus? So rhombus, I think back to what I had over here. Rhombuses are special, if I do a little side note here, because they have 4 congruent sides. And their other very popular fact, remember, is that they have perpendicular diagonals. Okay? So if we see any of those characteristics, it's going to be a rhombus. So let's go through our choices here. Choice 1 says AC is congruent to DB. Well, if I look at those choices, AC congruent to DB. Those are my diagonals, and if I think back, my diagonals are not congruent for a rhombus. My diagonals are congruent for a rectangle. So this first choice here sounds like it might be a pretty good option. So I'm going to kind of put a little arrow next to that one because that's where our gut's going so far. But let's talk about the other ones to be sure. It says AB is congruent to BC. AB is congruent to BC. Well, if those two sides are congruent, the opposite sides of my original pieces must also be congruent. So 4 congruent sides means it's definitely a rhombus. So not choice 2. Choice 3 says AC is perpendicular to DB. Well, AC is my diagonal, BD is my diagonal, and thinking back, rhombuses do give us right angles at the diagonal, so it's not choice 3. And again, those were both my 2 big ideas. The last one says AC bisects angle DCB. So AC is bisecting angle DCB. That other characteristic that was in the rhombus properties was that it makes congruent angles. I know my picture doesn't show it very well. So if you look back on page 2, this is also a property of rhombuses. The diagonals bisect opposite angles. So it's not choice 4. So going back, we were correct with our initial guess here of choice 1 because choice 1 said the diagonals were congruent. This is like a paint mess over here now. Those are only congruent for a rectangle and a square. We are talking about a rhombus. Okay? All right. Last one. Quadrilateral ABCD with diagonals AC and BD shown in the diagram below. Which information is not enough to prove the shape is a parallelogram? So parallelogram is at the top of our tree, remember, so it's got only the very basic characteristics. Let's go through each one and cross them off as we find which ones are true. So choice 1 says AB is congruent to CD and AB is parallel to CD. Well, if I have a pair of congruent sides and those same sides are parallel, that is enough information right there to prove to me that the rest of the shape is a parallelogram. And I know that because these pieces, A, B, and C, D match. So if you have a pair of congruent and that same pair is also parallel, that's going to force it to be a parallelogram. Choice 2, AB is congruent to CD, which we already marked, and BC is congruent to DA. Well, right there shows me that I have 2 pairs of congruent sides, and again, that's enough information, not choice 2. Choice 3 says AB is congruent to CD. Again, we had that marked from the start. But then it goes on to say that BC is parallel to AD. So notice the side change here. Now they're saying, well, these 2 sides are parallel. Sorry, the top side is parallel to the bottom side. So all I know is that 1 pair of sides is congruent, 1 pair of sides are parallel. That actually does not work because with only 1 pair congruent and the opposite pair being parallel, we don't know what's actually happening in between there. It's not enough information as we had in choice 1 and choice 2. So choice 3 is going to be our answer. And if we talk about why choice 4 is correct, choice 4 talks about how you have 2 pairs of parallel sides. And again, just like we said with congruent, if you have 2 pairs of parallel sides, that's enough because you know what's going on with all 4 pieces there. So I know I just threw a lot of information at you. That video is much, much longer than I anticipated it, so I really apologize. But these properties are super important that you know, so I would flip back to page 2 specifically on the bottom and maybe put those on a flashcard for yourself. Like, what are the properties of a parallelogram, rectangle, rhombus, and square? Okay, because you're going to use them every single day the rest of this unit. Okay, I'll stop talking now. Bye.